Good morning. Good afternoon, everybody.
Hello.
Good afternoon. So we just give welcome to the SLAN lecture series. We'll just give a few minutes for more people to join, and then we'll kick off immediately. Thank you very much.
Yes, ma. Good afternoon, ma.
Good afternoon, Dr. Adejumo.
Thank you, ma. How are you, ma?
Very fine, thank you.
Okay. We are waiting.
Yes, just 2 more minutes, and then we'll start. Okay, good afternoon, everybody. Welcome to SLAN's lecture series. It's 2:02 right now, and I did say we'll start in 2 minutes. So we are going to start very quickly. So what I'll do is I'll do a quick introduction of our speaker today, and then we're going to kick off with his presentation, which is going to take about 30-45 minutes. Then after that, we're going to have some questions. If you have any questions while the lecture is going on, you can type in the comment in the chat section, or once the lecture is over, you will be given the platform to ask your questions and the speaker will respond. Thank you very much. So today we are going to be listening to Kharbal Kaltho. He is a member of SLAN, Society of Landscape Architects in Nigeria. He's an experienced landscape architect and also an architect with a rich background in regional planning and landscape spatial analysis and design. He has participated in numerous regional, state, and campus master plan projects in northern Nigeria. He's a researcher with numerous publications and technical reports in watershed conservation, restoration of degraded landscapes, and climate change adaptation. He is the founder of Design Infinity Studios firm, and is also the current chair of IFLA Africa Committee on Communications and External Relations. He's a member of the International Union of Conservation of Nature, IUCN, Commission on Environmental, Economic, and Social Policy Specialist Group on Sustainable Use and Livelihoods, and also a member of the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, and International Union of Forest Research Organizations. Thank you so much, Kharbal, for joining us today, and you can start your presentation.
All right. Thank you, Toby, for that wonderful introduction, and thank you for setting up this meeting. I would like to recognize the former IFLA Africa president, Professor Tunji Adejumo. He started up the series the last time and gave an extensive overview of the UN biodiversity declarations and other aspects that pertains to landscape management in Nigeria and globally. So, and thank you, Toby, for setting it up. I'd like to also acknowledge that there are many participants in this lecture series that are not necessarily landscape architects. So we'll be welcoming their diverse vantage points in the discussions that we'll be having today. And also we'll try to scale down the terminologies so that it will be understandable by all. Thank you so much. I will be sharing my screen now. All right. So our topic discussion today is nature-based solutions and its application in watershed management. It's an important topic because a lot of issues that we're facing today currently has to do with a failure to recognize the basics of on which our civilization is built upon, which is nature. It is the foundation upon which our cities are built. It's the foundation on which we get our sustenance. And so the right interaction with these natural systems will ensure the sustainability of humans on Earth, and our understanding of how these systems are interrelated also affects our well-being and other aspects. We have a growing consensus globally on the need to preserve nature and to ensure that it is sustained for future generations to come. So basically the challenges that we'll be discussing on has to do with watershed management, and then the application of nature-based solutions. Conventionally, you have built infrastructure solutions that is dominating project-based watershed management, that is intervention of disaster-prone areas. Engineering solutions are widely applied, but over the years, they are proving to have failures in terms of their sustainability and also their deficiency in incorporating biodiversity in the restoration projects that those interventions target. So you find out that stormwater drainages, grey infrastructures are laid on waterways, and so it totally negates biodiversity. Aquatic life form is lost because they're just drains. And then the applications of this grey infrastructure is also an indication that we're forgetting an important aspect, that when you have stormwater drains in cities and urban centers, people think that when flooding occurs, we need more drainages, or we need to widen them. But the issue is that you're not solving the problem, you're only transferring it. So you find out that where those stormwater drainages deposit those huge amounts of water, it creates huge erosion problems. And that's what we're generally facing. Our focus of today will be based on agricultural landscapes, and that will be the focus of this watershed, rural agricultural watersheds. So there is an aspect of urban watershed which will not be the focus of our discussion today. So we'll be dealing with rural agricultural landscapes, and I'll shortly explain why that subject matter is important. So the structure of our presentation goes like this. Is my audio clear?
Yes, it is.
Hello.
Kharbal. Yes,
All
it
right.
is clear. Thank
you. All right. Okay. So this is the structure of our presentation. We'll be introducing the context and the concept. The context is watershed, and the concepts that we'll be highlighting is nature-based solutions. And then We'll also look at the global challenges and the relevance of watershed management. And then we'll look at nature-based solutions for watershed management, examples of the Shika watershed, and we'll have another example of a project that I recently participated in, which was the mapping of gully erosion sites and generation of land resource inventory data with a geographic information system frameworks for Niger State. It was a project sponsored by the World Bank and NewMap, as Nigerian Watershed and Erosion Project. And then we'll be looking at the need for a collaborative approach in dealing with the issues of watershed because of the multiple stakeholders involved, the community, the regulating bodies, the landowners, the policymakers, the designers, and then the land users. And then we'll be looking at also a project which I and my team published at the IUCN publication, that's the Sahe Riverbank failure, which was also used as a case study in the International Agricultural Organization of the UN. So they used that as a case study in their report. And then we'll just look at some actions and recommendations that we need to take looking forward. So with that, I would like to begin the presentation with explaining the context. The context is the watershed. So as we all know, the watershed represents a geohydrological and topographic delineated area that drains into a single channel. Now, going by that definition, every piece of land on Earth is a watershed because water drains from that land to a specific channel that is then deposited into streams, rivers, and then finally into the ocean. So the watershed also has some components which are biological, because in terms of biodiversity, the plant life and other living organisms. And then it's a physical component because it deals with the terrain, the slope, the geography, and other landforms that influence the direction and the interference or storage of water as it drains down. And then the watershed also is a social component because you have people, livelihood. It has a cultural element in it because it's waters represents a huge significance in ontological terms or religious terms. You use it for baptism, use it for ablution, and so on. So the need for it to be clean cannot be overemphasized. It's also the source of water for many cities. They rely on reservoirs to provide the water demands for cities. And we all know that water crisis is looming. It's a critical issue. It's also, so these are some of the components that make watersheds keenly important for our discussion for today. And then the map by the side shows a map of Nigeria and the various hydrological systems that intersects and weave through the landscape. So Nigeria is a highly hydrological country. In fact, the name comes from one of its rivers, the Niger River. So it's an important focus. And why agricultural landscapes? We are aware that about 70% of Nigerians engage in subsistence agriculture. So it represents a significant number of people involved in land use practices, or this is a large population that affects the landscape. So the kind of agricultural practice will heavily impact on the health of ecosystems, of rivers, of streams, and the side effects that their mismanagement can cause, like flooding, biodiversity loss, soil erosion, land degradation, and loss of soil fertility. So, and also the government has also pushed forward the need to turn to agriculture. We find the agencies that are mandated to govern these water systems are driving for floodplain agriculture, which is called Fadama agriculture, and other kinds of agriculture. So what kind of systems are they currently using, and what adverse effect is it having on our waterways and the impacts that is causing on cities and in other parts of the nation? So just to explain the concepts, we started with the context, that's the watershed. So explain the context here. The context, the concept is nature-based solution. There's also a growing consensus internationally to do things that is to take action in the way we advance our civilization in a more sustainable way and in a way that respects nature, biodiversity. You have so much moves on being eco-friendly, sustainability, and so many concepts like that. So the notion of nature-based solutions stems from an understanding, a deep understanding of ecological systems and the need to act wisely in managing this system. So the definition as coined by IUCN in 2016 states that that nature-based solutions are actions to protect, sustainably manage, and restore nature or modified ecosystems that address societal challenges effectively and adaptively, simultaneously providing human well-being and biodiversity benefits. So there are three actions involved. One is actions, and that's one is protect. The second is to manage, and the third is to restore. So these three triple actions are involved in nature-based solutions, and they are usually area-wide interventions that systematically looks at the source of problems and not just the symptoms. A lot of our interventions today is to address specific challenges that are symptoms of broader watershed ills, like stream bank protection or gully erosion. When you patch the symptoms, it doesn't remove the underlying cause of the problem. So nature-based solution seeks to address the underlying cause of these issues that cause disturbance to the landscape, and then address them systematically through the application of conservation knowledge, and it's really action-oriented. And then the image by the side, the figure by the side shows the societal challenges that is addressed by by nature-based solutions, climate change, food security, water quality, flooding, health and well-being, and also livelihood as economics. And so there has to be a balance between all these human needs and how we address them. So there's nature-based solutions for each of these categories, and we're really going to focus on nature-based solutions for agricultural landscapes. So there's nature-based solutions for well-being, for instance, that takes a look at psychological needs of people and how natural interventions can address issues of depression and so on. There's nature-based solutions for various issues, challenges, but we'll be looking at nature-based solutions for agriculture. But this agriculture also touches on water quality. It also touches on livelihood. It also touches on climate change. And so it's focusing on that also helps to address other issues. Now, so these are the societal challenges that nature-based solutions, or NBS acronym, addresses. So we'll be looking at some of their intervention, or some of how this intervention is done, at the heart of it is the water crisis, which is important. So nature-based solutions are also applied at the landscape scale, at the landscape level. So it addresses issues like watershed management and disaster risk prevention, like landslides, addressing stream bank erosion, addressing water quality, and addressing biodiversity loss. That's the image by the right. So it addresses a whole range of issues systematically. We'll have some examples to show that. Now, nature-based solutions are also gaining prominence on the global scene. The United Nations Environmental Programme report in 2019 recognized nature-based solutions as an important aspect of dealing with climate change. And so the United Nations Framework Convention on Climate Change also, from the Paris Agreement, mandated nations to come up with nationally determined contributions to address societal challenges. And out of the nations that have submitted, 167 have added nature-based solutions as part of their submissions. And so it's gaining prominence also in the United Nations, as our team shows that the UN have dedicated ecosystem restoration to be a decade 2021 to 2030. And a lot of efforts have been streamlined to support nature-based solutions as a proven means of addressing challenges. So UN is on top of the issue. And then we'll look at why are we focusing on agriculture for this discussion. Then when you look at the global challenges that we're facing, one of it is climate change, which is on top of the issues that we're facing. And climate change is basically caused by greenhouse gas emissions that impacts on the stratospheric ozone layer and causes global warming. So, and that global warming then affects natural systems, and a kind of convulsion begins to happen in nature, systems being disrupted. So the image by the left shows the major greenhouse gas emitters by economy. Now, if you look at it, electricity and heat generation contributes 25% of greenhouse gas emission. That's from coal burning and fossil fuel burning for energy needs. And a staggering 24% is contributed by agriculture, forestry, and other land use changes, usually the removal of forest covers for agricultural needs. So agriculture is a huge contributor to greenhouse gas emissions. In fact, it's almost twice the amount of the transportation industry. Surprisingly, transportation industry contributes about 14% of greenhouse gas emissions. That's combined. We're talking about aviation, sea transport, land transport, and all their emissions combined. It's not up to that of agriculture and forest. So we're looking at an important aspect that needs to be addressed. And if you look at how these emissions are being generated within agriculture, is the charts in the middle. NO2, that's nitrous oxide, contributes 38% of that emission. CH4, methane gas, contributes 32%. So on top of it is nitrous oxide, 38% is produced by, is a leading cause of greenhouse gas emission within the agricultural sector. Then biomass burning and rice production, and then manure management and lower percentages, 12, 11, and 7 respectively. So the issue with so the issue with carbon dioxide, why it's why it's mostly termed as the major greenhouse gas gas emittant is because it's more predominant. That's the chart by the lower right corner. It's carbon dioxide has 76% of the total mass of greenhouse gas emissions within the atmosphere as produced by all these sectors. But then if you look at the impact that carbon dioxide has on the environment, is less compared to other gases like the nitrous oxide, which is 6%. How does 6% contribute more than 76%? That's because nitrous oxide has a lifespan of 100 years. It remains active in the atmosphere for 100 years, and it is between 298 to 300 times worse than carbon dioxide as a greenhouse gas. So that's alarming. That's the chart by the lower left corner. It's 300 times more harmful than carbon dioxide. The reason carbon dioxide is mostly used as the currency of measuring greenhouse gas emission because of its prominence. It's 75% of the emission in the atmosphere. So where does this nitrous oxide come from? Methane is 16%. These are all agriculturally induced greenhouse gases. Nitrous oxide occurs as a result of mineral-based agriculture, usually urea, NPK, nitrogen, phosphorus, potassium, which is used by this 70% that we mentioned in Nigeria that are into subsistence agriculture. So, and why is this shift occurring? Because of the neglect of naturally formed nitrogen to meet plant demand. People are bypassing these natural processes just to get quick results and instant harvest. And so, but it also has its side effects because the soil usually begins to lose its ability to produce natural nitrogen for plants. And then that's where you have the issue of soil degradation and then the loss of harvest and so on. So the economy, whilst it's being turned to agriculture, it's also dependent on this mineral-based agriculture. People are stranded because the government has not supplied the agriculture. But how have we been producing our food in the past? It's by these natural processes, allowing the land to heal, the vegetation, providing green cover on the land so that microbial community grows and builds, and other farming practices. So the kind of farming practices that 70% of people in Nigeria undertake will have impact on the sustainability of the nation. And that's why we need to bring out these conservation practices to the public, to the limelight, so that this 70% becomes actors and drivers in the landscape. So you can't have everybody employing professionals to tell them what to do. But if this becomes common knowledge, which is called best practices, we now have 70% workforce pursuing sustainability, or actors in our drivers in sustainably managing our resources. Now, is this knowledge not available? It is. The problem is that these conservation knowledges exist within academic literatures, and so the wider society is not privy to some of these informations, and they are practicing agriculture as usual. So the culture needs to be changed in agric, and hence you have a new agric culture. So we're looking at cultural changes to transform the agric sector. So that's what we discussed. Greenhouse gas emissions is an important issue that we need to address in the way we carry out our agriculture. So other environmental challenges that stems from these factors are land degradation, biodiversity loss. Biodiversity loss is important. It's an alarming factor. the fact that our agriculture is also monolithic, that's is you have most lands produce one single crop, and then during the dry season, the land is left bare and exposed to all kinds of forces, wind, erosion, and so on. And then that biological community is being lost. It also leads to disaster risk reduction, disaster risks like flooding, because those vegetation that keep the ground intact is lost. So wind blows it, and when the rain comes, eventually during the rainy season, there's nothing that holds the ground in place. So there's a lot of siltation and that flows into streams and water bodies, carrying the mineral-based fertilizers that have been applied on the land, because it doesn't go. Some of it is sediment bound, like phosphorus. It attaches to sediment particles, and nitrogen flows underground as base flow in the groundwater, and then it enters into the streams, and then you have over eutrophication. That's the stream, a host of biological life begins to grow, like nymphia and lotus plants that clog waterways and makes it difficult for navigation. It also increases toxicity in water reserves like dams. And then the absence of this vegetation around stream bodies also leads to depletion of oxygen, because when floodplains that are flooded with water, there's a phenomenon called where flooded soils lose oxygen. It's the presence of plant life through their roots that inject oxygen bubbles in the soil. Now, when soil loses oxygen, it becomes anoxic, that's the term, and it can easily mobilize heavy metals like manganese and so on that is difficult to treat in water treatment systems. So a huge investment is made in water treatment in the municipalities, and some of it is not fully treated, and it goes into the urban water systems, and a host of issues emerge from that. So water security is an important issue that nature-based solutions can apply. So this shift to just gray infrastructures, whenever people need water, they just build dams and invest heavy on that infrastructure and neglect the source watershed that provides the water in that reservoir. So a lot needs to be done in treating source watersheds, because they are the source of water supplies for many cities. So then food security and livelihood, the loss of soil fertility and the shift to mineral-based fertilizers also results in low fishery yields, because the waterways are flooded with silt, and it impacts on fishery production, because this sandy, disturbed waters affect fish breathing in water, because it enters into their gills. Now, if International Federation of Landscape Architects has also moved to take action on ecological restoration by making some declaration in the just concluded World Congress, and the IFLA president, IFLA Africa president, and other parties to the meeting also were signatories to the declaration that were made. IFLA recognizes the need for health and well-being and sustainable development. It also recognizes the link between nature and the cultural aspects of design for healthy ecological systems and communities, and the interdependence to enhance each of these sectors. So IFLA is collaborating with IUCN to advance ecological knowledge. IFLA is working on making these resources available so that professionals and practitioners and land users can have these resources. IFLA also established a working group on agricultural landscapes, and it's working and doing a lot of work in that aspect. So IFLA is in the forefront of this agenda. So we'll quickly look at nature-based solutions and its application. This is a case study of the Shika Watershed, a project that I did during my MLA. And I just want to highlight the conceptual ecological model for agricultural landscape. The diagram by the left shows the landscape adjacent to a stream. And what you need to look at is the climatic factors that impact on the land. So the different climatic zones determine the kind of vegetation that you find on the land. So climate affects vegetation. And then you look at the forces that act on the landscape to distort it or to enhance it. So you have land use practices, whether it's agriculture or infrastructure or settlement. Each of these has their impact. For agriculture, you have impacts like stream crossing. People crossing streams is a huge point where sediments enter into the streams. You have rural roads in these agricultural communities, which are usually perpendicular to the stream. And so it creates a channel by which eroded soil flows into the water bodies. And you have the settlements themselves, the imposed structures that create these impermeable surfaces that now drains the water in that settlement. And then you have stream bank erosion, other issues like that. So that runoff that results from all these actions carry with it pollutants, whether it's the domestic pollutants or the agricultural-based pollutants, and they find their way into the soil, either on the surface or beneath the soil as base flow. Now, the significant pollutants that we're looking at for agriculture is majorly phosphorus and nitrogen. And as I earlier mentioned, nitrogen, mineral-based fertilizer applied in agriculture produces nitrous oxide, which is 300 times worse than carbon dioxide as a greenhouse gas. So this nitrogen flows as a base flow. It flows under the soil. So you need vegetation to denitrify this excess nitrogen. So some vegetations like legumes have been known to denitrify the soil, and riparian vegetation through their root system take up this nitrogen. So we need a system of agricultural patches or what we call buffers within the agricultural field to trap all these chemicals before they find their way into the waterways. Then phosphorus moves, it attaches itself to the sediment particles. So if we don't have buffers that trap these sediments and take up the phosphorus, you have huge intake of phosphorus into the reservoirs or the streams. These chemical imbalances will either mean an over amplification of certain species within the waterways like Nymphia lotus and so on, that clogs waterways and so on. And it's generally a problem for municipalities treating municipal water. So it's important to establish these buffers to trap these nutrients, to filter the water before they find their way into waterways. So a lot of crop land management needs to happen within the landscape, within the agricultural fields. So this is a diagram that shows how this green shows where these buffers will have more significant impact on the landscape. It's supposed to be applied along contour lines. So certain physical information or data is needed to apply these interventions. So that's where the professionals come in to provide that knowledge base on where best to apply these interventions and where it will have more impact. For instance, if you are dealing with water quality, it's better to apply it at the first order streams. That's the beginning of the waterways, where the land is more intricately connected with the stream. So that's where to attack water quality. If you're talking about flooding, you deal with it downstream at the second or third order streams. Streams are categorized based on order. The first one is the starting point, and when it branches, it becomes second order. When those second order branches again, it becomes third order down to fourth order streams. Then usually the fourth order streams becomes rivers. So these are some of the interventions that need to be done. Now, the professionals provide the knowledge. The land users are the actors. They are the ones that use their implements to till the ground. So they need this knowledge to be able to apply this. Then another issue is what should be the width of buffers? And generally, you find policies on certain dimensions for streams and rivers and so on. But really, when you want to consider buffer width, you have to determine the goal of that buffer. What do you want to achieve by for that buffer? So there's buffer width for flood, there's buffer width for pollutant removal, and there are certain systems by which you can calculate buffer width. A simple example is that the efficiency of buffers needs to be about 1/20 of the landscape that supplies the adjacent or the crop field. So 1/20 can provide sufficient buffer impact in terms of water quality. But when it reaches 1/50, the efficiency is reduced. Other systems of determining buffer width is the slope. So higher gradients require wider buffers to be able to filter it because of that force. So those are some of the dynamics involved in establishing buffer width. But you have basic standards that may or may not meet the specific needs. So you have to determine what you need, what you want to achieve in terms of the buffer width. And like I said earlier on, headwaters are the best place to target interventions for water quality, while the lower order streams, if you want to do flood control, so you address it there. These are some photos of the Shika watershed, and you see agricultural practices down to the very edge of the waterways, and a host of problems emerge from that. So examples of these nature-based solutions within agricultural lands and their impact is some of the terminologies that have been developed over the years within conservation is agroforestry, as in bringing back the forest that was removed to create room for agriculture. So creating a balance and placing those interventions where they will make more impact. So you have grassed wetlands that can filter runoff from agricultural fields before they enter into the stream. And you have windbreakers that can also trap dust particles that carry the minerals that have been applied on the soil. Some of it is fertilizer, some of it is pesticides or herbicides that are sediment bound. So windbreakers can trap them. Then you have grass filters, usually at the very edge of the streams to create that defense, the filtering effect before it enters into the streams. You have grass waterways, similar to bioswales that is applied in urban settings. And what they do, they filter this runoff. So it's like the natural farm drainage. Bioswales with, and let me just talk a little about urban water sheds. It's not the subject of our discussion, but having these naturalistic systems within urban settings helps. it reintroduces biodiversity. You have butterflies and so many other insects that have vital functions within urban settings. And I'll give you an example. The loss of biodiversity amplifies certain species to become prominent. And malaria is usually caused by mosquitoes. And when you have, but the thing to ask is there a natural defense mechanism against the excess of mosquitoes? And there is. Many insects feed on mosquito larvae, and they are most effective when they are in waterways, close to waterways. For example, the adult larva mosquitoes are consumed by predaceous diving beetles. These beetles we have around. So they feed on mosquito larvae, and they are mostly found close to water. You have the dragonfly. We used to see it a lot when we were kids. The dragonfly, it eats up mosquito larvae. You have frog, toads, and tadpoles. They also feed on larvae, mosquito larvae. Those are not their staple food. But it's this kind of biodiversity that checkmates certain environmental phenomena from going overboard. So introducing nature back into urban settings can greatly solve some of the problems that we seek for solutions in medicine, for instance. So there's some branches of study like medical geography that looks at certain phenomena and how nature is contributing, or the impact of nature being absent, accelerating the growth of certain pathogens that affect humans. So that's just an example of this grass waterways within urban settings. And it also have good benefits in urban settings because the excess volume of water is allowed to infiltrate within that environment. So you don't spend a lot on urban irrigation because the water remains on the ground. And then that volume is reduced, that causes erosion at where it's being deposited. And also by these grasses within the bioswales and other forms of urban landscape interventions green infrastructure plays these roles. So these are examples of how our landscapes are meant to be when we incorporate nature-based solutions in them. Another examples are grass strips within the agricultural landscapes. So they perform those functions, like I said earlier, filter and treat the water naturally, remove these chemical pesticides. And then nature-based solution is not solely a natural approach. You can integrate it with gray infrastructure, built infrastructure. So it's not a standalone solution. There are some areas where you need to integrate gray infrastructure to create the stability for the biodiversity to grow. And when they grow their roots, they become stable. And then those gray infrastructure can then give way. But solely gray infrastructure negates biodiversity. So the image at the lower left corner is an example of how you can integrate both gray infrastructure and to support or to create the stable base for your green infrastructure. And you find this a lot in terrace, the Chinese, the lush plateau in China, a system of terrace. That's the image in the first image in my introductory picture. That's the lush plateau. It's a combination of natural built infrastructure and then natural infrastructure. They create these stable terraces, and then the vegetation supports the growth, and then it becomes an excellent landscape. So more examples, there are a host of conservation practices that is driven by landscape architecture to provide some of these solutions. This is the Fanyan Dune Terrace, which is applied mostly in East Africa, Kenya. They apply it a lot. They create these ditches on slopes so that the soil that is washed down is trapped within these ditches, and then vegetation grows within the ditches that performs all those functions of the nitrification, phosphorus removal, and then the biological community grows within that ditch, and instead of it just running down into the stream. So you have this image. The first one is your typical agriculture with ridges even perpendicular to the stream, just washing it off. So that understanding that soil is a resource, it's an important resource that is, in fact, soil is a non-renewable resource because it takes ages for it to develop and become is able to support advanced biological community on it. So, and that's why when large-scale degraded landscapes are being restored, you have to start with the microbial community, building it up. Then that community can support more higher vascular plants that will now regenerate the landscape. So by this approach, about 35% of soil organic matter is retained on the land, and crop yield is increased by 25% for those that have applied this method. And we're seeing this kind of approach is gradually being implemented in this a case in Cross River State by a new MAP, Nigerian Erosion and Watershed Management Project. And though there's a lot of challenges with their approach, they are mostly project oriented, but these nature-based solutions are gradually finding their way into the status quo. And we hope that they can be mainstreamed as an important way of addressing our degraded landscapes. So it's an example where the land was terraced. I'll just quickly look at a case study. This case study was a assessment that myself and some of my colleagues, Ibrahim Gibku, Gulo Mustafa, we undertook and published in 2017 in the IUCN publication, Commission on Environmental, Economic and Social Policy. So that it was an assessment of the Saye River bank failure located along the Zaria-Kaduna Expressway. And its part is within the Galma Watershed. So it's a stream, it's a river that dissects an existing rail line and the expressway. So the erosion had persisted for about 8 years. We started the study. We had an 8-year study period where we used satellite images to show the expansion of the river. And then we also monitored the kind of intervention that was adopted by the government. They used RIP structural method, that's green infrastructure. So it did not consider the biological community, and there wasn't a stakeholder response. The community was not involved. And so the project failed, and the situation is getting worse. We published that report, and incidentally, the Food and Agriculture Organization of the United Nations picked that as a case study to demonstrate nature-based solutions for agricultural, water management, and food security. And what they did with that case study is to highlight 4 indices to determine success or failure of nature-based solutions. One is transdisciplinarity of the project. What are the parties involved in making that a reality? And then the rewarding the custodians. Are the community involved? Then institutional collaboration. What are the parties, institutional parties, whether it's the Ministry of Water Resources, Ministry of Environment, are they party to this engagement, or Ministry of Transport because it crosses rail and road line? So the as we reported, these three components were not present in the rehabilitation work that was carried out in the Sahel River Bank, and so it failed because the approach did not consider this collaborative framework and getting the parties involved. And so that was reported in the link is here, you can check the report. And then another project that I recently participated in is the GIS survey and mapping for gully erosion sites and generation of land resource inventory within a geographic framework for Niger State. So we see new map now beginning to make assessments, and that will be part of my recommendations just shortly. We need to carry out these assessments of the state of our environment and then publish them, and hopefully they become, they find their way into policy documents that now becomes guidelines for design. So because design is not just the solution, it has to be part of policy or guidelines. So this report was carried out by a urban and regional planning and geospatial information firm, PANCRO. And how I got involved was just a casual conversation with the project leader, Emmanuel. He was sharing what they were doing, and I now brought up some suggestions. I said, oh, this is an area that I'm also keen on. And I asked, what interventions are they planning on? He told me already they have already made arrangements for structural engineering solutions for the gully sites that were identified. And I brought up the idea to use nature-based solutions, and then it was part of the report. The last chapter was all about an alternative to green infrastructure. So nature-based solutions was part of the report. The assessment used geospatial information, which is an important tool for landscape architects to get their hands on. It gives, it helps in generating flood vulnerability maps, and it helps in delineating the watershed so that knowledge on where best to place interventions can be informed, and you can make decisions that are science-based. So this assessment took into consideration there was field work that looked into about 600 settlements within Niger, and selected 6 gully erosion sites to graphically illustrate nature-based solutions. So that just came in as an add-on into the report. The report was just an assessment to guide whichever contractor that they will provide to intervene. So we made recommendations, myself and another landscape colleague, also Ibrahim Gerku, were the part of the team that made recommendations for this nature-based solution. So we made recommendations for flooding, and then also for gully erosion. 6 sites were selected in Kuzuntu. This one is in Agai. So, and 6 other sites, and then graphically illustrating the kinds of interventions that needs to go into resolving gully erosion systematically. So this is just an example. We mapped out 5 levels of interventions that needs to be made. First, you need to establish what the floodplain is, and then you can now make determinations as to where your interventions would make most impact. So we had interventions in level 1, regenerating the stream and establishing a nature-based stream conveyance system, so that it's not just a gray infrastructure that just funnels the water, but it's an array of green infrastructure systems within the stream conveyance system that conveys the water. Then we had interventions at level 2, which is the land immediately adjacent to the stream body itself. So recommendations on nature-based stabilizations of the gully were made. And then level 3 intervention is 10 meters away from this your initial second level intervention, where we recommended integrated riparian buffers along the corridor. So we had separation, primary separation buffers. This delineates, gives boundaries for agriculture and then for conservation purposes. And so a host of those kind of recommendations were made for this project. And then the actions that we need to be taking as professionals is to go into more multi-stakeholder engagement and institutional collaboration, both for the institutions and then practitioners, and then collaborate with allied professionals. Like I said, these were planners that I was part of their project. So if we sit down in our own little bubble, whatever we know cannot find its way into policy or decision making. So landscape architects need to collaborate with the actors, the land legislators, those that manage, land managers, planners, those that deal with the landscape on a high level. We need to collaborate with them. We need to be part of their teams, whether it's regional, city, urban master plans. We need to partake. We don't have to lead for, we can lead, but we can also participate. We can lead in our own specific area. Let's identify our niche and make our own contributions within the status quo that we find ourselves. Then we should make assessments, independent assessments and valuations of the state of our landscapes. We can document them, like the example I mentioned earlier on was an independent assessment that we did in 2016, and then we published it in 2017. It was not financed at the time. So, but just describe your landscape, do the assessments, do the reporting, and then publish it. It finds its way gradually into policy or international organizations that our nation consults to provide recommendations. And so a lot of work has been done by the Landscape Architectural Performance Series in trying to create tools to evaluate landscape benefits, because that's some of the missing links, that people do not value what these natural landscapes can contribute, and there's difficulty in establishing monetary value to those interventions. So there are certain tools on this website that we can look at, some that measure the carbon sequestration benefits of the project, and others that measure different aspects so that these ecosystem benefits can be measurable and can serve as a motivation. An example is where an assessment was made on a source watershed, and they made evaluation of the cost of water treatment and then versus the benefits the landscape interventions can contribute in terms of reducing that treatment cost. So these are some of the tweaks that we can begin to make our projects more relevant, and they can be bionomics, that's monetary terms associated with the benefits. What is the cost of keeping a forest as opposed to removing it for agriculture? So you determine the biodiversity benefits, you can evaluate it. The air quality benefits can be evaluated. The water treatment quality can be evaluated. How much dollars, how much naira can that be if you leave it or if you disrupt it? So we should go into this kind of assessments. And there's a number of assessments that we're currently working on with our team to assess agricultural practices or the state of certain water channels. And so these are the kind of things that we can begin to do. Then public awareness, like I said earlier on in the lectures, some of this, they are not new knowledge per se. It's available, it's within conservation data. In fact, the landscape architecture is all about nature. It's mostly about nature-based solutions. It is our terrain. So we need to make it in a public consumable form. There's a project we're working on creating visual, what do you call it, flyers that rural agricultural practitioners can easily see and apply. So we want them to become best management practices. And then funding is an important aspect for these nature-based solutions. It requires a lot of funds, and usually the status quo are not keen on funding nature-based solutions because of the uncertainty. We don't know whether it will work or not. So they are more settled with gray infrastructure interventions. So we need to find out sourcing pathways to fund this kind of interventions. Like the project in Niger was funded by the World Bank, and Newmark, and then Niger State government itself. So we need to find alternative funding solutions, and then design and implementation. Whenever we have the opportunity to make impact, we should do it to the best of our ability. And so policy, and one of the recommendations that we can also look at it needs to be there has to be political will in making this possible, is to take policy actions in recognizing and support social ecological stewardship or civic ecology innovations as national assets towards sustainable development by giving it priority and financial support similar to conventional economic entrepreneurship grant schemes. So there's a lot of grants for entrepreneurship and so on, sowing, knitting, and so on. So we need this kind of grants for environmental stewardship. So if our assessments can be packaged properly and we push it forward, we can see grants coming for this kind of projects, ecological initiatives. Then the restoration of diverse native and productive perennial agricultural landscape is needed for upland crop management, as it is the focus of our discussion, agricultural landscapes. We can't continue as usual, so we need a system of riparian vegetation cover along aquatic corridors, and it is needed to restore biomass and regenerate soil organic matter to foster biological diversity and productivity. And it also impacts on livelihood, because the person that cannot afford fertilizer can apply these systems, and it has to be a systematic approach. Sustainability cannot be done by one party and then the others neglecting it. So it has to be a collaborative approach. And so that's how we can move forward. So I'll conclude my presentation with this. Thank you very much for listening.
Thank you so much, Kharbal, for your presentation. It has really been a very enlightening one, and focusing on the United Nations Decade of Ecological Restoration. What you're trying to say to us now is that these nature-based solutions are some of the things that we can do between 2021 and 2030, which is the decade, that the UN has established as the Decade of Ecological Restoration. So I'm going to go into some questions now that some people have asked in the chat, and we'll just quickly run through them before we close. Okay, so from Degradation is asking, what he would like to know how nature-based solution can be used in agricultural planning of flood-prone farmland. So farmland that are flood-prone. What are your suggestions on what the nature-based solutions that can be used for agricultural land? And then should I run through all the questions or you answer them one after the other?
Okay. Okay. You can run through them.
Okay, great.
So
the second question is, how do local farmers use nature-based solutions to solve pest invasion on crops? For instance, koala bed is a major issue in rice farms. And also his third question is, how do landscape architects make Nigerians accept nature-based solutions in wetlands and watershed management than instead of opting for engineering solutions which are not sustainable and probably not as costly as, costlier than nature-based solutions. So how do we accept nature-based solutions as opposed to the current engineering solutions that we use? And also, final question from Dr. Adejumo. He's asking, how do you advise on how do we reset the landscape architecture pedagogy in line with our current infra vision? Those are all the questions.
All right. Okay. Let me see if I can address some of them, and I also give it back to our Honorable Prof to also shed light on it. So for like the presentation I made also addressed like question 1, 2, and 3, but let me just highlight some specific actions that need to be taken. So for floodplain plain agriculture, is you need to apply some of these interventions like that we mentioned earlier on, riparian buffers, vegetated strips, contour farming applications like the Fanyan Dune terrace that we highlighted earlier on. So there's a number of interventions that can be used in reducing the risk of flood in these flood plains. And you have to create that buffer. There has to be that buffer. Usually you find floodplain agriculture going down to the stream. Leave that part for riparian buffer. You can have agroforestry products instead of seasonal crops there. Agroforestry products like lumber wood. You can have orchards, vegetation, fruit-bearing plants. Put something that is more long-term, close to the stream. And then the more seasonal crops can come after the vegetated buffers. Then within that agricultural landscape, apply some of those conservation practices like border cropping. You establish stiff-stemmed hibiscus plants around the border. Some of them are like this bitter leaf, and there's this one that was used for biomass. Fuel. So you apply them to bound your field. So, and it's like contour, but it's like it creates a dune. So whatever water falls within your field is retained in that field. So that helps a lot. So there's a lot of interventions that can be applied. Hopefully by this webinar, we can have a catalog of interventions because they have to be site specific. It's not prescriptive. I can't give you a specific plant because it may not be suitable for that particular land area. So there are native species within that context, physical context, that can be applied to apply these interventions on. Then pest control, it goes back to the point I raised earlier. This monocropping allows certain species to prevail. When you have only rice or only cereal crops in a vast land, those other species that checkmate certain pests will find an open field to propagate, and that's where you have to apply herbicides and pesticides. So introducing this natural occurring landscapes within the agricultural fields helps to foster certain biological communities that attack these species, these pests. I gave the example of mosquitoes that is prevalent in urban settings. When we strip all biodiversity, some of these plants need are repellent to mosquitoes, and some of these insects eat up mosquito larvae. And so when you have diversity, it checkmates a lot of things. There's a lot of story. If you read the history of Australia, when the colonials went there, they introduced certain species, and because there was no competition, the predator and prey relationship was not there. Those introduced species were just prevailed. They become invasive species. In IUCN, there's a committee on invasive species, where the species is a green species, but it colonizes, it takes over. Like in Australia, they had cactus that just colonized the whole place. They had to introduce a caterpillar that now ate up the cactus. And then the colonials brought in rabbits that now ravage their agriculture. They had to introduce a species of fox that feed on that rabbit. Then the fox was introduced, and then the fox hunted the rabbits. Later on, the rabbits were proven too cunning for the fox. The fox started eating the ground nesting birds in Australia because there were no predators. So the balance of nature needs to be achieved in order to mitigate some of these pests and so on. So introducing diversity in crops, multiple crop growing, you can combine your cereals and your legumes together. So they combat and they play beneficial roles together. So, and then the status quo, how do we shift? One of it is by this kind of platform that SLAN has organized, enlightenment of these issues that are pressing. It was alarming for me to see that agriculture contributed to greenhouse gas emission more than the entire transportation system combined. So while we're looking at innovations or transitions from fossil-based fuel to electric cars or hybrid cars, those interventions alone cannot solve the issue if the way we grow our food kills us at the same time. So we need to look at what sector has more impact. What are the actors? Who are the actors that drive that practice? How can we sensitize those practice actors? Like the Ministry of Agriculture in Nigeria or the Water Resource, while you're promoting agriculture that do not become a danger to the livelihood of the people or the systems that we rely on. So those are some of the conversations that needs to be done. So in terms of improving landscape architects, the advice that I'll give is to review our curriculum. We need to make our curriculum suited with this. The landscape curriculum generally is rich, but we need to have specific topics like we have some on restoration, but we need to be grounded on ecology, on this participatory science kind of knowledge where we teach engagement and public partnership, public engagement and sectoral collaboration. Some of this social knowledge needs to be in the curriculum, and the science-based knowledge needs to be in the curriculum, and then soil. I remember in my school days, we had a professor from Agric that was the one that taught us soil science. So it was a huge enlightenment to understand how soil is formed and that not every sand that we see is soil. So the soil is the biological community in relationship with this physical substance that makes it soil. And regeneration practices need to start from this microbial level, not just tree planting. You find that many people just let's plant trees. but it doesn't really regenerate in a sense because it has to start from the soil. So some of this foundational knowledge-based conservation science needs to be advocated within our curriculum. And then geospatial knowledge also is highly relevant. It gives us scientific basis for reviewing or assessing the landscape. So it's also important, GIS knowledge within landscape practitioners. So I'll give it back to Prof to give us more.
Thank you, Kharbal. Yes, if Dr. Adejimo wants to chime in, and also I would like to put Dr. Memuna on the spot slightly for her to for her to also comment on the question about how do we reset the landscape architecture curriculum in line with current IFLA vision. And if anybody else has any other question, please raise your hand or you can quickly type in the chat box. Thank you.
Well, again, it's a wonderful presentation, and I feel happy. Yesterday, I was online watching the young landscape architects representing Kenya during the Kenya and Sweden. I realized the four people that represented Kenya are just young landscape architects that came on board about 4 or 5, maybe 6 years ago. All these, I didn't see them, and they did wonderfully well. And I was talking to somebody here. I said, "Well, these guys have taken over," not knowing that today you guys have really shown that that there are more intense intellectual energy among our young landscape architects in Nigeria. It's wonderful. We want to appreciate Kaltho for that. I have nothing to add. I think he has said it all, and I agree with that one. Maybe Dr. Memuna is there; she'll be able to add anything. Thank you very much.
Thank you, Dr. Adejimo. So if you have any other questions for now, I think that this is a huge rallying call for everybody to figure out what your practice as a landscape architect will solve, how your practice as a landscape architect will solve the ecological degradation problems that we have in the country today, globally, Nigeria, anywhere, wherever you are. So hopefully with more of this kind of discussions and focusing on different people's specific areas of interest in landscape architecture, we can find a proper, I guess, policy document or something like that to put together and say that, okay, this is what landscape architecture is doing about the ecological degradation in the country. Does anybody else have any questions, comments? No? Okay, great. I really want to appreciate Kharbal again for presenting his project and his work on nature-based solution in agricultural landscapes. Okay, does Dr. Memuna have speak? Yes.
Okay, can they hear me? Hello, Toby. Hello, SLAN. And hello, Kharbal. As you can see, I'm actually on the journey. Okay. So thank you very much. Your presentation was very interesting and quite enlightening. And I don't have any question. This is, we all know landscape architecture. That is, I mean, we can concentrate on landscape planning. That is at the regional level. We can concentrate on landscape design, and we can concentrate on detailed landscape planning. So what Kharbal has done today is falls under what we call detailed landscape planning. You know, how you can actually solve a problem. You know, not just the concept, but you know, the nitty-gritty of it, its application. So thank you very much. And I'll say well done, Kharbal, and well done to the organizers. I'm also on the road, but listening to you.
Yeah.
But anyway, I listen quite interesting, and I hope the younger ones too. You know, those in practice. I don't want to mention the names. You know that you can also come up with similar topics. You know, build your confidence and present to us. And I hope we also get more of our members tuning in and benefiting from this. And I hope this is going to be on our platform, or we're going to share this.
Yes. So this session is currently being recorded, and we're going to share it on our platforms before the end of this week.
Okay. Okay, thank you very much.
All right, thank you very much, everybody, for joining in this lecture series. We're going to be putting together another one before the end of this year, and that's going to be shared on our WhatsApp platform and every other platform that we have: Instagram, Facebook, and Twitter. Thank you very much for everybody joining us. Bye.